got a question on the modulus function, but it's actually a modeling question. So we've got the number of subscribers to two different music streaming companies, NA and NB. The curves are shown on the right, and we're asked, it's over a 5-year period, so 5 is labeled on there. We're asked to use the equations of the models to answer the questions. So find the initial difference between the numbers of subscribers to A and to B. Okay, so those are our y-intercepts. So if I put in t as 0 into NA, then I'll get the modulus of -3, which is just 3, plus 4, I'm going to get 7. And if I do the same for NB, I'm going to get 8 minus the modulus of -6, which is 6, so 8 minus 6, which gives 2. And therefore 7 minus 2 is 5, but it's not just 5 users, because it's actually the number of subscribers in thousands, so it will be expected that we write 5,000 subscribers. Moving on, when company A, when time is capital T, company A reduced its subscription prices and the number of subscribers increased. And we can see that happening. It's going down and then it comes back up. Suggest a value for T, giving a reason for your answer. So it's surely going to be here where the number of subscribers bounces back up. And it's going to be where we get the critical value in our modulus function. So when T is 3, T equals 3 here. The curve hits minimum. Going back up after. Just some words like that, I think, are fine. Right, now find the range of values of little t for which NA is greater than NB. Okay, I'm just needed a bit more space. Let's write these equations down again. So we've got NA and NB, and I've actually forgotten what they are. So t minus 3 plus 4 and 8 minus modulus t minus 6. So I want to find when NA is greater than NB, and I can see on the graph it's like this line here is where NA is above NB, because NB is down here, and then also over here. So what I actually want to do is find the points of intersection, and then it's going to be everything to the right of this one and everything to the left of this one. So let's not worry too much about it being inequality. Let's solve the equations. I'm going to first of all find out this one here, which I'm going to call T2, and then this one here, T1. I'm actually going to deal with T2 first. I think it's a little bit easier because for T2, we've gone beyond the critical value for both, and actually beyond 3, which is where the critical value is, the modulus function doesn't do anything. I'm just going to get T minus 3 plus 4. And then for this one over here, when t is beyond 3 as well, the t2 minus 6 is positive, so again it won't do anything. So it will become 8 minus bracket 2t minus 6. Okay, whatever we put in here, if say t is 4, for example, we get 8 minus 6, 2. The modulus of 2 is just 2, so you just ignore it. Now we can just tidy it up a little bit. T plus 1 is going to equal 8 minus 2t minus 6, actually it's going to be 14 minus 2t. So then 3t will equal 13, and t is 13 over 3. And just to reiterate, actually that is t2. So if we had the modulus function not kicking in for both of those, when we go back beyond the critical value, we actually are going to have to use it. So instead we're going to get minus t minus 3 plus 4. We can also see that there's a negative gradient. That's another way to think about it to help us along the way because we're going to get a minus t here. And that is going to equal 8 minus 2t minus 6, which will become 8 plus 2t minus 6. You'll be really careful with this, I think. But that is going to be what's going on. Again, we get a positive gradient. You can see that it's working okay. So t minus, oh, that's a minus t. Sorry, almost forgot. So minus t plus 3 plus 4, so minus t plus 7 is going to equal 8 plus 2t minus 6. That's actually going to become 2 plus 2t. And then I'm going to get 3t equal to 5. So t2 is 5 over 3. And we're very nearly done. So it's everything lower than sorry, that was t1. Apologies. Everything else was okay. A few little typos going on. Okay, so it's everything lower than t1, although technically it has to be greater than 0. The answers don't quote that, but I would say that 0 is less than or equal to t, which is less than 5 over 3, or t is greater than 13 over 3. Now it does ask for set notation. I always write it like this first, and then I'm going to go with set notation. So it's actually the set of t such that, then we just write the same thing. Instead of or, we use a union. Then the set of t such that t is greater than 13 over 3. Okay, that is our answer. That's the trickiest bit of the question, I think, dealing with that modulus inequality, not least because there's stuff going on outside the modulus, so be really careful when you're kind of thinking, does the modulus kick in or does it not? But this is what I would advise. Find the points of intersection, just be really careful, just look at, whether like what's going on with both functions at that point. The modulus function isn't actually doing anything. It's just, if it's already positive, so it's just ignoring. We just turn it into a bracket essentially. And then for the other one, where we've gone the other side of the critical point, it's making it negative because it already is negative, and then that will make it positive, and then we solve that to get the 5 over 3. Okay, very finally, state a limitation of the model used for company B. Okay, so we had it going up and then back down, but look what's going to happen if we follow it along. It's actually going to become negative. So our model is predicting eventually we'll have a negative number of users, and that is obviously a limitation because that can't actually happen. So something along the lines of the number of subscribers will eventually become negative in company B's model. Okay, challenging question, but hopefully you're happy with everything we've done. Good effort.